You think you're living right here, right now, but science suggests that might be an illusion. What if time isn't flowing the way we believe? What if every moment you've ever lived, past, present, and future, still exists, stacked together like pages in a book? Einstein warned us, the closer you get to the speed of light, the more time fractures. And in the next few minutes, you won't see the universe the same way ever again. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. What happens when you approach the edge of everything we know? When you race toward the speed of light, not as a metaphor, but as a boundary carved into the bones of physics itself? We're told it's impossible, that no object with mass, no person, no spaceship, no particle of matter can ever reach that sacred threshold. It would require infinite energy, bending all the laws of the universe until they snap. But impossibility hasn't stopped us from imagining, from building simulations, from creating experiments that push our minds right to that edge, right to the place where time begins to unravel. MIT once created a strange game, a slower speed of light. You begin like any other player walking through a simple digital world. But here's the twist. You're not speeding up. Instead, the speed of light is slowing down around you, and that's when things start to change. At first, it's subtle. Colors begin to shift. Shadows stretch in unnatural directions. The world starts to warp, not because your eyes are failing, but because physics is breaking around you. You've stepped into a realm where light, space, and time no longer obey the rules you grew up with. And that's the truth hidden beneath the surface of everyday life. Light is not just illumination. It's the thread that weaves together reality. It defines what we can see, what we can know, and how fast we experience time. But when you tamper with it, even just in theory, reality starts to show its cracks. As you collect more orbs in the game, simulating the experience of nearing light speed, your perception continues to distort. The colors twist into shades you've never seen before. This is the relativistic Doppler effect in action. Normally, light from an object reaches your eyes at specific wavelengths, allowing you to perceive reds, blues, greens. But when you move fast, really fast, those wavelengths begin to compress and stretch. The reds shift into infrared, the blues into ultraviolet. Suddenly, invisible worlds become visible. You begin to see heat itself. You begin to see light that was always there, but hidden just outside your reach. Reality, it turns out, has layers, and motion is the key that unlocks them. But light doesn't just bring color, it brings form. And as you continue moving forward in the simulation, something even stranger happens. The world ahead of you becomes brighter, almost blinding. Behind you, darkness. This isn't just an illusion. It's called the searchlight effect, a consequence of special relativity. As you barrel forward, photons ahead slam into your eyes in greater density, amplifying light and sharpening vision. The universe behind can't catch up, its photons fall away, leaving you in shadow. This is what approaching the speed of light feels like. Not a blur, not a thrill ride, but a warping of the senses, a breaking of the universe's symmetry, a forward-facing tunnel of fire, behind which the past fades into cold. And here's where the real paradox begins. Because from your perspective, inside this relativistic experience, you don't feel like you're moving faster. Your breath is steady. Your steps feel normal. Your heartbeat is unchanged. You are still you. What's changed is everything else. This is Einstein's genius. Reality is relative. You are the center of your own clock, and motion distorts everything around you to preserve the constancy of light. To keep the speed of light consistent, the universe sacrifices time, stretches space, and breaks every intuitive law you thought was permanent. Time slows down, distances shrink. The faster you go, the more the universe bends to uphold this cosmic covenant. And yet, you feel nothing. Think about that. You could be racing across the galaxy, approaching 99.99% the speed of light, and from the inside, it would still feel like a calm walk on a summer day. But the outside world wouldn't agree. To observers back home, time is moving normally. For you, time has slowed to a crawl. Maybe a minute passes on your ship, but years flow by on Earth. Maybe a second, maybe a century. That's the terrible beauty of light speed. It's not just a measure of motion, it's a rupture in time. It means that if you could somehow reach this speed, and you can't, not with mass, not in this form, you could cross the entire galaxy in an instant from your point of view. But when you arrived, the galaxy would be older. Entire civilizations may have risen and fallen, stars may have burned out, planets may have changed forever. To you, it was just a blink. To the cosmos, you disappeared into legend and returned as a ghost. This is not science fiction. This is what would happen if only the speed of light weren't an impenetrable wall. We've proven it in our labs. Clocks flown on high-speed planes tick more slowly than their earthbound counterparts. GPS satellites account for time dilation in their calculations because if they didn't, your phone would guide you to the wrong city. The effects are real, just too small to notice in our slow human lives. But push the speed high enough, and time itself begins to break. And here's the most humbling truth of all. Light doesn't experience time, not in any way we understand. From a photon's point of view, if it even has one, there is no before and after, no journey, no distance. A beam of light, leaving a distant galaxy and arriving in your eye billions of years later, doesn't experience the passing of time at all. It exists in a kind of frozen present, stretched across the cosmos. And yet it carries history. It carries memory. It tells the story of stars, of creation, of time itself. So as you approach this threshold, as you imagine what it might be like to stand on the edge of the speed of light, know that you are brushing against something sacred, something woven into the fabric of the cosmos, something that cannot be crossed, but that defines everything on this side of the line. Light is the limit, and beyond that limit, our understanding begins to unravel. What if I told you that every time you looked around, you were only seeing a narrow sliver of the truth? The visible world, the one filled with reds, greens, and blues, is merely a fraction of what's really there. Your eyes are tuned like a radio to one narrow band, but outside that spectrum exists a hidden universe. The glow of infrared heat, the shimmer of ultraviolet fluorescence, the invisible whispers of light beyond human perception. But here's the astonishing part. You could see it. If you moved fast enough to bend space and time, reality itself would pull back its curtain, and you'd witness what was always there, waiting. At near light speed, the universe doesn't just change how it feels, it changes how it looks. Because motion doesn't just shift your position, it warps the very light coming toward you. It distorts color, stretches wavelengths, and reveals truths you were never meant to see. This is called the relativistic Doppler effect, and it is not just a scientific concept. It is a key to unlocking the hidden spectrum of existence. Let's return to our simulation MIT's thought experiment, where the speed of light gradually slows. As your virtual self gathers orbs and light becomes more sluggish, colors begin to mutate, reds become deeper, blues shift to violet, then something miraculous. Shades you've never seen before begin to emerge. Why? Because the wavelengths of light are no longer obeying your old rules. As you move faster, the light from objects in front of you gets compressed. It's squeezed into shorter wavelengths, many of which lie beyond human sight. What was once infrared heat, unseen and intangible, shifts up into the visible spectrum. You start to see heat glowing off the walls, the ground, your own hands. Ultraviolet frequencies, once the hidden language of cosmic radiation and starborn particles, slip downward into view. The air begins to shimmer like a dream you didn't know you'd forgotten. Suddenly, the world is not as you knew it. You are no longer a creature walking through a familiar space. You are a being peeled open to the secrets of light itself. The room you thought you understood is now a spectrum of fire and shadow. Walls breathe, shadows hum, even darkness carries color now. The Doppler effect isn't new. It's what makes the siren of an ambulance rise and fall in pitch as it moves past you. The waves of sound stretch and compress depending on the source's motion. But with light, the stakes are far more profound, because as light shifts, so does the truth. In astronomy, scientists use this same principle to understand the motion of galaxies. A star racing away from Earth emits light that appears redder, its waves stretched as space itself expands between us. A star racing toward us appears bluer, its waves compressed. Redshift and blue shift aren't just visual quirks. They are evidence of cosmic motion, of expansion, of history and progress. And now, imagine that happening not to distant galaxies, but to the world right in front of your face. That's what approaching light speed does. It turns your surroundings into a kind of Doppler kaleidoscope. The faster you move, the more of the spectrum becomes visible. The past, hidden in heat. The future, encoded in ultraviolet. You don't just move through space, you unlock it. But there's another consequence of this acceleration, and it hits you in the eyes like a supernova. Brightness. As your speed increases, the photons from the world ahead of you begin to pile up. More and more of them slam into your retinas per second, not because the world is shining brighter, but because you are moving faster into the stream of light itself. It's like sticking your head out of a car window, but instead of wind, you're colliding with photons, the raw particles of light. This is called the searchlight effect. The space ahead becomes blindingly luminous. Even dark objects radiate. Shadows vanish. It's as if the future itself is burning through the veil, trying to reach you all at once. Turn around, and the opposite happens. The world behind you dims, retreats, recedes. Fewer photons reach you now. You are leaving the past behind, and with it, its light. In this way, vision becomes directional. The universe no longer surrounds you. It flows forward like a river you are racing up against. It's not just brightness or color that changes. It's the entire structure of perception. The walls around you begin to lean in. The tunnel ahead seems longer, deeper, sharper. It's as though the geometry of reality is melting and reforming in real time. This is not an illusion. It's a shift in how space and time deliver information to your brain, because every single thing you see is a message carried by light, and motion changes how fast those messages arrive. Here's the strangest truth. Everything you're seeing is already in the past. Even now, in this moment, watching this video or reading these words, your eyes are not seeing the present. They are interpreting light that had to travel from your screen to your face, from the stars to your telescope, from the past into now. Motion changes that timeline. At relativistic speeds, the delay becomes noticeable. You begin to witness the world as it was, not as it island, a momentary lag, stretched longer and longer, until reality begins to echo and fragment. And it gets stranger. As your field of vision warps, something eerie begins to happen. You start to see things that shouldn't be visible. Objects around corners, scenes out of place. This isn't a hallucination. It's the result of aberration of light, a phenomenon where high-speed motion changes the angles at which light reaches your eyes. The result? A wider field of view. The faster you go, the more you see not just ahead, but to the sides, as if time and space are folding around your face, letting you peek into places once hidden. You become an oracle, not because you see the future, but because you see more of what's already there. The world was always this rich. You just weren't fast enough to see it. It raises an unsettling question. How much of reality are we blind to, simply because we're too slow? The answer? Almost all of it. You, sitting still, are only glimpsing the shallow end of the spectrum. You think you understand color, light, heat, but the universe is a symphony of frequencies, most of which you'll never detect. Your body is a filter, your speed is a limitation, and the truth is far, far bigger than your biology. But relativity, this haunting, beautiful physics of motion, gives us a gift. It shows us how to lift the veil, how to catch a glimpse of what lies beneath the visible, how to peer through the shadows and into the spectrum of the impossible. And so, as you approach light speed, you do not just move faster, you awaken. You become a creature of vision, beyond the visible, a traveler of hidden light. You see heat, you see radiation, You see the universe reveal its deeper layers because you dared to move faster than your eyes were designed to handle. And in that revelation, one truth echoes louder than the rest. Reality is not what you see. It's what light allows you to see. Time is the one thing you never question until it betrays you. You wake, eat, work, sleep. Seconds tick by like falling raindrops. Days pass. Years accumulate. You measure your life by time. You remember birthdays, deadlines, anniversaries. You believe, perhaps unconsciously, that time flows the same for everyone, everywhere. But it doesn't. That's the first lie. The second is even more disorienting. Time isn't fixed at all. It bends, it stretches, it breaks. Not in theory, but in practice. Your body is a clock. So is the Earth. So is every star and satellite. And the faster any of them move, the slower those clocks begin to tick. This is time dilation, a phenomenon so strange, so counterintuitive, that even Einstein hesitated when he first saw where the math was leading. The rules are simple, yet world-shattering. The faster you travel through space, the slower you travel through time. As velocity increases, time decays. Inch by inch, second by second, your present starts slipping away from everyone else's. At near light speed, this effect becomes extreme. Spend a year on a spaceship moving fast enough, and when you return to Earth, a decade may have passed. Walk through your front door, and your friends may be older. Your city may have changed. The world you left behind has moved on without you. From your perspective, only 12 months went by. You aged normally. You breathed the same number of breaths, but Earth aged tenfold. You stepped into time like a diver into deep water, and when you surfaced, the ocean had moved. This isn't science fiction. It's been proven. In 1971, physicists flew atomic clocks on commercial airplanes, then compared them to identical clocks left on the ground. The difference was minuscule fractions of milliseconds, but it was there. The airborne clocks had ticked more slowly. Time had passed differently, depending on the path you took through space. We have to correct for this constantly. The satellites in our GPS system orbit Earth at thousands of kilometers per hour. Because of their speed and their distance from Earth's gravitational well time, moves differently for them. Their clocks, if left uncorrected, would drift out of sync with ours, ruining the navigation system we depend on. So we program them to lie, to tell time as if they were standing still on Earth. And all this, just for moving a little faster, a little higher. Now imagine going much faster. Imagine approaching the speed of light. At that velocity, time doesn't just slow down, it threatens to stop entirely. From the perspective of a beam of light, there is no time, no before, no after. A photon travels across the galaxy and reaches your eye. But for the photon, that journey was instantaneous. It experienced no aging, no waiting. It simply was. Photons are timeless, eternal. They carry the memory of stars born before Earth even formed, and they carry it without decay. But you're not made of light. You're trapped in time's current, until, that is, you start to push back. Let's return to the simulation. In the MIT game, your walking speed remains the same throughout, but as you collect more orbs, the simulated speed of light slows, bringing relativistic effects into play. It begins to feel like you're accelerating, rushing forward through the world, distances shrinking before you. But here's the trick. You're not speeding up. Your steps are still the same size. What's changed is time. Your internal clock is ticking slower than the environment's. The game world, still operating at normal time, starts to collapse around you. Roads seem shorter. Buildings rush past. Everything feels compressed. And that's exactly what real relativity predicts. From your perspective, the faster you move, the shorter distances appear. If you were traveling in a spaceship at near light speed, a star 10 light years away might seem only 1 light year distant, and you'd reach it faster, not because you're breaking the speed limit, but because space has folded under your feet. And all the while, time outside your ship would continue as usual. People on Earth would experience the full duration of your voyage, years, maybe centuries. But inside the ship, you'd feel like you arrived almost instantly. two observers, two timelines, both correct, both real. This is not fantasy. This is how the universe works. It makes us ask, what is time, if not a shared experience? If two people can live through entirely different spans and still occupy the same cosmos, is time even real? Or is it just a convenient illusion, one that breaks down under pressure? And here's the most terrifying aspect. You'd never notice it happening. You wouldn't feel time stretching. There'd be no warning, no vertigo, no siren announcing that you'd slipped out of sync. It would feel normal, completely normal. And yet, somewhere, someone else would be watching your seconds turn into centuries. You would vanish into velocity and return a relic. Relativity doesn't just distort time, it distorts meaning. It forces us to confront that the universe doesn't owe us a consistent experience. It doesn't care about synchronized clocks, shared calendars, or human expectations. It plays by the speed of light, and everything else is negotiable. But time dilation doesn't just affect travelers. It happens to everything, everywhere, all the time. Right now, time is moving slightly slower for you than for someone at the top of a mountain. Why? Because gravity too bends time. That's right. Not just speed, but mass. The closer you are to a large object like Earth, the slower your time moves. The difference is tiny, but measurable. It means your head ages faster than your feet. Your watch ticks faster in an airplane than in a basement. Time is not universal. It is local. It is personal. It is yours. And yet it is not yours at all, because you can't control it. You can't slow it down or speed it up at will. It moves through you like a river you cannot swim against, unless you ride light's edge, unless you dare to challenge the boundaries of mass and motion, unless you ask the unthinkable, what happens if you catch time and hold it in place? Einstein gave us the equation. Nature gave us the proof. And you are left with the implications. That time is not a line, but a fabric. That it bends, folds, slows, and frays. That it may not be absolute at all. And that perhaps, just perhaps, the past, present, and future are not moments we pass through, but layers we exist within, all at once. So when you ask, what time is it? The answer depends entirely on who's asking and how fast they're moving. Time is broken, and in the brokenness, a new kind of truth begins to emerge. If time can stretch, then space can shatter. We think of distance as fixed as a fact. 10 miles is 10 miles. 1,000 light years is 1,000 light years. But what if that number isn't real? What if the distance between 2 points isn't a line, but a feeling, a sensation warped by the speed at which you move? Because as time slows down, space folds in. This is one of the strangest truths of special relativity. The faster you travel, the shorter distances become from your perspective. What once seemed unreachable draws near. What once stretched across eternity now collapses into a single breath. And it means this: at the edge of light speed, space itself becomes negotiable. Let's go back to the simulation, the strange little MIT game where walking doesn't get faster, but light gets slower. As more orbs are collected, the laws begin to crack. Time slows, perception bends, and something strange starts to happen. The world feels smaller. You're still walking at the same speed, but you're getting somewhere faster. Why? Because when time breaks, so does distance. The paradox of motion is this: you feel unchanged, but the world warps around you. In physics, this is called length contraction. From the outside, you appear to stretch. But from the inside, space begins to shrink. The road shortens, the stars draw close, the universe leans in. And the closer you get to the speed of light, the more radical this collapse becomes. Imagine a star 10 light years away. If you stayed on Earth, watched the ship leave, and waited, you'd count 10 years before it arrived. But inside that ship, moving at relativistic speeds, the journey would feel instantaneous. Not because time is cheating, but because space has folded to meet the traveler. The star didn't move. You moved reality. And this isn't a trick. It's baked into the structure of space-time itself. Einstein didn't just tell us that time and space are linked. He told us they're two sides of the same coin. You cannot bend one without bending the other. Time slows, space shrinks, velocity increases, distance collapses. Light speed becomes not just a limit, but a lens one that distorts the entire stage of existence. To move fast, then, is to become an artist of reality, a sculptor of space-time. But here's the haunting truth. The collapse of space is only visible to the traveler. To everyone else, the journey took years, centuries perhaps. From Earth, your ship was seen crawling forward, following the relentless speed limit of light. Telescopes tracked your motion. Clocks ticked. History moved on. But for you, the destination was a blink away. You stepped into the corridor of velocity, and the walls of the universe slammed shut around you. And this opens the door to the most poetic horror of all. You can outrun time, but not its consequences. Imagine leaving Earth at near light speed. You're headed to a star 40 light years away. For those back home, the voyage takes 40 years. But for you, the journey lasts mere moments. You close your eyes at launch and open them at arrival. But when you look back toward Earth, it's not the same world anymore. Your family, decades older. Your friends, gone. Your city, changed. Maybe even your species. You've traveled through distance, but you've also traveled through time. You've lost everything familiar not because of speed, but because of the cost of speed. That's the cruel joke of relativistic travel. You gain the stars, but lose your place in the world. And yet, inside the ship, you would feel normal. Your muscles wouldn't stretch. Your heartbeat wouldn't change. You'd walk the same way, breathe the same way, laugh the same way. Because that's the magic and the madness of relativity. You remain the same, but everything else warps around you. It's not unlike dreaming. In sleep, seconds in the real world can stretch into hours behind closed eyes. You wake, and only minutes have passed while inside. You've lived a lifetime. Except here, the dream is reversed. You are the one who skips ahead, and the rest of the universe is caught inside the slow motion of time. But the question must be asked, what even is distance, if it bends like this? What does it mean to say that Alpha Centauri is 4.3 light-years away, if that number changes depending on who's measuring? If you move fast enough, it's not 4.3, it's 3, then 2, then 1, then nothing at all. And what of a black hole so dense, so massive, that space itself crumples into a funnel? Get too close, and distance evaporates. The center pulls you inward, not by force, but by erasing every other path. It's not that you're falling into the hole, it's that all directions now point toward it. The same principle applies here. Speed isn't just motion, it's a weapon that rewrites geometry. The faster you go, the fewer steps it takes to reach anywhere. The galaxy becomes a map folded in on itself. Every point collapses toward you, because light is no longer the ruler by which space is measured. And if this all sounds like magic, it isn't. It's math. It's reality. It's happening right now. Particles in accelerators are doing this as we speak. They zip through vacuum chambers at 99.9999% the speed of light. And for them, distances shrink, time slows, mass increases. We don't see it directly, but the equations demand it. The experiments confirm it, and our understanding of the cosmos depends on it. So what, then, is a light year? It's not a distance. It's a promise. A vow that says, this is how far light can travel in a year, if you stand still, if you wait, if you measure it from the outside. But that promise changes when you move. It bends when you accelerate. It collapses into something smaller, something closer, something you can touch. And that is the great betrayal of the stars. They look so far away, but they're not. Not really, because distance, like time, is not what you thought it was. It is not fixed. It is not sacred. It is not even real in the way your senses crave it to be. It is a veil, and if you move fast enough, if you reach toward the edge of light itself, the veil lifts. The stars are not far. The galaxies are not distant. The universe is not separate. It only seems that way when you're standing still. What if the world you see isn't where it truly is? What if every step you take, every object you pass, every beam of light you trust is slightly misaligned, a subtle illusion, a cosmic sleight of hand, not because your eyes are broken, but because light is late? This is the next fracture in reality, a phenomenon so disorienting, so counterintuitive, that even professional pilots and physicists struggle to wrap their minds around it. It's called the aberration of light, and it means this: the faster you move, the more reality appears to shift around you, not because things are moving, but because you are. Let's return to our simulation. The world has already begun to bend, colors have warped, time has fractured, and distance has collapsed. Now, another layer of perception peels away. You're still walking at the same pace, still collecting those glowing orbs. But suddenly, something strange begins to happen. You're crashing into walls you thought you'd avoided, missing targets that seemed square in front of you, reacting too late or too soon. You start to doubt your timing, your coordination, your instincts. But it's not you, it's light. It's the lag. Because even light, that cosmic constant, takes time to reach you. Every photon that strikes your eye had to travel, even if only across inches. Every image you see is a delay, a memory, a whisper from the past. And the faster you move, the more pronounced that delay becomes. You are no longer seeing the world as an island. You are seeing it as it was. Imagine a high-speed spacecraft slicing through space. From the outside, it's a silver arrow, but from within, the pilot notices something strange. The stars ahead of the ship seem to cluster toward the center. The ones to the side appear to shift forward. Even the stars behind seem to lean inward. The sky is warping. The field of vision narrows into a kind of forward-facing tunnel, not a result of glass or atmosphere, but of velocity. This is the aberration of light, and it's not a trick of the eye, it's geometry. Here's why. As you move faster, the light hitting your eyes doesn't come straight on anymore. Photons from the side must catch up to you, so they arrive at sharper angles. The faster you go, the more extreme this effect becomes. At relativistic speeds, almost all incoming light appears to come from the direction of motion. The sky folds inward. The cosmos stretches around your path, like a tunnel made of stars. You are not moving through space. Space is collapsing into your direction. This effect is subtle at low speeds, but as you approach the speed of light, it dominates your entire sensory experience. And not just visually, physically. You'd have to move differently, react earlier, turn before you're ready, because by the time light reaches your eyes, the world has already shifted. It's like living with lag, but not in a video game. In life, in perception, in motion itself. And now, everything becomes more complicated. Objects no longer appear where they truly are. You begin seeing things from perspectives that would normally be impossible. Your forward motion allows you to glimpse the sides of objects you'd otherwise never see. Corners become exposed, horizons wrap toward you. The straight lines of reality begin to curve. In other words, your field of view expands. The faster you go, the more of the world becomes visible, not because your eyes improve, but because space is being warped around your velocity vector. You can now see into places you once thought hidden, not through X-ray vision or magical insight, but through the fundamental bending of light itself. This isn't science fiction. This is what relativity requires. It's the same effect that lets us see the underside of the moon as it orbits Earth, not because the moon tilts, but because light bends. It's how gravitational lensing lets us glimpse galaxies behind other galaxies by bending the path of light, like a river around a boulder. Aberration of light is a reminder. Seeing is not believing. Seeing is negotiating, and velocity rewrites the terms of the deal. There's a haunting metaphor here, too, because aberration doesn't just distort space, it distorts time. Remember, everything you see is already in the past. When you look at a friend across the room, you're seeing them as they were nanoseconds ago. When you look at the moon, you're seeing it 1.3 seconds ago. The sun, 8 minutes in the past. The nearest star, over 4 years behind. And when you move fast enough, the depth of that past increases. You begin to fall behind reality, to witness the world not as it is, but as it used to be, like a ghost walking through memory, like an echo of yourself watching echoes of everything else. And here's the strangest part. From your perspective, everything feels normal. You're still moving forward. Your body still obeys its rhythms. But the world is warped. The angles are wrong. The shadows fall in unfamiliar directions. Light arrives too late to make sense of. You're always one moment behind, and yet one step ahead of everyone else. Because while you fall behind in observation, you leap ahead in motion. The faster you go, the faster you leave the static world behind. You become a bullet fired through history, a traveler pulling the future toward you while dragging the past behind like a shroud. And eventually the question becomes, can you trust your own senses? Can you rely on your eyes when even light itself is distorting around you? When the world tilts to meet your speed? When the laws of vision begin to fail? Because light isn't loyal to your understanding, it is loyal to the universe. And the universe bends for motion. In this way, the aberration of light becomes more than a scientific phenomenon. It becomes a philosophical mirror. It forces us to ask, what is real, if even the act of seeing cannot be trusted? If the faster we move, the more the world lies to us not to deceive, but to remain consistent with deeper laws? At the end of the day, we are beings of perception creatures who build entire realities on the flicker of light and the rhythm of time. But what happens when both betray you? You learn a darker truth. The universe doesn't show itself as its island. It shows itself as it must filter through light, bent by motion, delayed by distance. And so, as you race toward light speed, the cosmos doesn't just become brighter, it becomes uncertain. And in that uncertainty, you're no longer a passenger. You're a distortion. You're a ripple in a reality that no longer knows quite where you are. At some point, the journey stops feeling like motion and starts feeling like distortion. Not because your speed increases, not because your engines roar louder, but because reality begins to break in subtle ways. The further you push toward the speed of light, the more the universe itself becomes unstable, not in structure, but in perception. The world doesn't just rush past you. It twists, it shifts, it warps. This is not just travel, this is transformation. Let's step back into the MIT simulation one final time. You're walking forward, just walking. But as the speed of light is artificially lowered around you, everything begins to feel strange. The walls bend inward, corners stretch like rubber, objects seem to lean into your path before you get to them. You're not hallucinating, you're experiencing relativistic, warping the result of motion, altering how light behaves around your body. You're beginning to see what it would feel like to fly through the fabric of space-time, to use speed as a weapon against perception itself. At this point, everything starts to feel wrong. You look forward, and things appear closer than they are. You reach for objects and miss. You try to turn, but you're already too late. It's as if the game is cheating you, playing tricks with timing and position. But it's not the game, it's the delay of light. Every image your brain receives is outdated. Everything you react to has already happened. You're always a few steps behind, not because you're slow, but because Light Island, even at its staggering speed, nearly 300,000 kilometers per second light, is not instant. And when you move fast enough, even its speed begins to fail you. You have to think ahead. You have to move in anticipation. It's like navigating through fog with echoes instead of sight. Reality is no longer an anchor, it's a guess. And then the tunnel forms. As your simulated velocity increases, the light ahead doesn't just grow brighter, it collapses into a narrow cone. The stars and scenery you once saw, spread across your field of view, now funnel into a single vanishing point. This is known as relativistic beaming, a phenomenon caused by the piling up of photons in the direction of travel. Everything ahead burns, everything behind disappears. You are being pulled into your own momentum. But brightness is not beauty. It is a warning, because when photons are compressed into tighter and tighter waves, their energy increases. The infrared becomes visible. The visible becomes ultraviolet. The ultraviolet becomes X-rays. And eventually, if your speed is high enough, gamma radiation. The cosmos ahead of you becomes lethal, not metaphorically, literally. At extreme relativistic speeds, the very starlight you're flying into would fry your ship. The radiation from even ordinary background light becomes concentrated into deadly rays. The faster you go, the more dangerous the universe becomes. Motion reveals the hidden violence of space. But that's not all. Another strange effect begins to unfold, one that has nothing to do with damage and everything to do with disorientation. It's called the Penrose-Terrell rotation, a visual illusion that occurs when objects moving at relativistic speeds appear to rotate, even though they are not. You fly past a cube. From your point of view, it doesn't just streak past, it twists. It's as if the object is showing you more of itself than should be visible. Corners appear that should be hidden, angles stretch and bend. What was once familiar geometry is now a surreal hallucination of form and space. But again, it's not the object that's twisted, it's the light. Because light from the far side of an object takes longer to reach you than light from the near side. At high speeds, this delay becomes significant. Your brain tries to compensate, stitching together an image that feels coherent, but what you get is something impossible. Reality is lagging. And so, like a painter forced to use fractured brushstrokes, your vision becomes approximate. The cosmos is no longer a stage. It's a blur, a smear, a whisper of what it used to be. And this is the truth we don't often talk about when discussing space travel. At relativistic speeds, the journey becomes unknowable. Not because of distance, not because of time, but because what you see cannot be trusted. And if what you see is no longer real, what does it mean to travel? Where do you go if space is warped? What do you become if time is uneven? These are not hypothetical questions. They are practical ones, because even today, in our particle accelerators, we launch protons at speeds so extreme that they are flattened, warped, time-stretched echoes of themselves. From our perspective, they live longer than they should. They travel further than they could. They become something new, not by choice, but by motion. Motion changes identity. It changes presence. It changes fate. And so we ask, if a human were to travel this way, who would they be upon arrival? The answer isn't clear, because at some point, the distinction between traveler and illusion begins to blur. The ship moves, the clock slows, the stars twist, and all the while, the one inside feels normal, feels unchanged. But the world outside says otherwise, and eventually, the paradox becomes unbearable. You feel real, but you are being warped. You believe in time, but it is no longer yours. You believe in place, but space no longer behaves. And so the journey, this beautiful, terrifying, relativistic voyage, ceases to be a simple act of going from point A to point B. It becomes something deeper, something existential. It becomes a confrontation with perception itself. Because the faster you move, the more you lose your ability to witness the universe as its island light delays. Geometry bends, distance collapses, brightness blinds, time fractures. You are not moving through space anymore. You are moving through layers of distortion. You are moving through the veil between reality and illusion. And at some point, the only thing left to hold on to is this. You are a ripple in the fabric, a wrinkle in perception, a voyager not through stars, but through meaning itself. You thought it was just speed that bent time, but speed is only one side of the coin. The other is gravity. Not the gravity you think you know, not just the pull that keeps you grounded or tugs at falling apples. No, this is something deeper, stranger, something Einstein glimpsed when he realized that gravity isn't a force at all. It's a curve in the stage itself, a warping of reality. And wherever gravity grows stronger, time slows down. Let that sink in. It means that time does not tick evenly across the universe. It drips slower near mountains than it does at sea level. It slows in valleys. It stretches beside planets. It warps near stars. The cosmos is a terrain not just of space, but of time gradients, where seconds slip and stall, depending on how deep you stand in gravity's well. And this changes everything. because it means gravity is not just the shaper of orbits and planets. It is a natural time machine, a quiet one that doesn't require engines or tunnels or flux capacitors, just mass, just presence, just the patient, invisible hand of curved space-time. Let's bring it close to home. Right now, as you read this, your feet are aging more slowly than your head. The gravity at the floor is slightly stronger, and so just slightly time ticks slower there. It's not something you can feel. It's not something you can notice, but it's measurable. Atomic clocks have confirmed it. Climb a mountain, and you age faster. Lie in a valley, and you lag behind. It's not myth. It's math. It's not metaphor. It's physics. In 1959, a simple experiment known as the Pound-Rebka test confirmed this with startling clarity. Gamma rays were fired from the top of a tower and received at the bottom. The waves of light shifted slightly as they fell, compressed by Earth's gravity, a tiny change, but one that revealed an enormous truth. Gravity stretches time, and the stronger the gravity, the deeper the stretch. Near Earth, the effect is small. From head to toe, the difference is a fraction of a nanosecond per year. But widen the scope, travel closer to something massive, and the gap begins to grow. Take the Sunday. Its mass dwarfs Earth's, and its gravitational field runs deeper. Stand on Mercury, the closest planet to the Sun, and you are closer to this mass than on Earth, and the effect becomes visible. Time ticks slower there, not by hours, not by minutes, but by seconds, measurable seconds stretched across a lifetime. Over the course of 80 years on Mercury, you'd experience about 14 fewer seconds than if you'd lived on Earth. That's it. That's all. And yet, it is everything, because it tells us that proximity to mass alters your place in time. Now imagine cranking that mass up. Imagine falling toward a collapsed star, a white dwarf, a neutron sphere, a dead sun squeezed so tightly that a single spoonful of its matter outweighs a mountain. There, time slows more dramatically. Fall deeper still, and you reach the edge of science's comprehension, the event horizon of a black hole. Here, gravity's grip is so extreme that not even light can escape. But before you cross that line, something surreal happens. To a distant observer, you appear to freeze in time. Your motion slows. Your heartbeat halts. Your fall becomes eternal. Not because you stop, but because time itself does. From your perspective, you fall normally. You don't notice the shift. But from outside, the universe watches you vanish in slow motion, like a ghost, trapped in the amber of gravity's grip. And this is where the phrase, gravitational time machine, becomes literal. Because if you could survive the edge of a black hole, if you could hover just outside the event horizon and return, you would find yourself flung into the far future. Spend 30 minutes there, and centuries might pass elsewhere. It's not a theory. It's a prediction born from Einstein's field equations, a prediction that scientists and simulations continue to test. And while we haven't yet flown someone to the edge of a black hole, we've seen the time stretch in action. We've observed stars orbiting the supermassive black hole at the center of our galaxy, stars that follow paths so tight and so fast that their internal clocks differ from ours. We've seen the redshift of their light, proof that even their photons are aging slower before they reach us. The gravity near a black hole is a well so deep, time nearly stops. And yet, that's not the part that chills the spine. It's this. You could use that well. You could drop into orbit around a black hole, wait a few hours, and emerge to find that the universe has aged without you. Wars ended, empires fallen, stars born and gone. You remain young. The cosmos is old. You have jumped into tomorrow, and nothing, not even light, can follow. But there's a cost, because gravity doesn't just slow time, it distorts everything. Your vision warps. The light from surrounding stars bends into rings. Space stretches. Geometry breaks. The sky becomes a spiral, and your sense of direction becomes meaningless. You are no longer in space. You are in curved time, a realm where minutes and miles bleed into each other, a place where the math becomes unstable, where equations scream infinity, where our instruments fail and our models collapse. Einstein's theory predicts it, but even it can't explain what happens beyond, because beyond the event horizon, our understanding ends. We don't know if time continues, or if it folds. We don't know if space persists, or implodes. All we know is that at the edge, time hits zero, and beyond that, reality as we know it dissolves, perhaps into another universe, perhaps into a singularity, perhaps into a story not yet written. But what we do know is this: gravity is not just mass pulling mass. It is mass pulling time, and wherever mass grows, time breaks. So if speed can stretch time, and gravity can freeze it, then maybe, just maybe, the universe isn't a place at all. Maybe it's a canvas of distortions, painted in motion, and gravity and light. And maybe, just maybe, the story of time is not linear, but warped, bent around stars, twisted by black holes, stretched by movement, and stitched together by the very force we thought we understood: gravity. The sun does more than give us light. It bends the rhythm of time itself. We wake to its rise. We sleep by its fall. We mark our days by the sweep of its shadow. But hidden beneath its golden warmth is a gravitational weight so immense that it subtly, relentlessly slows time. Not in metaphor, in measurable seconds. And once again, the illusion cracks. Time is not universal. Even within our own solar system, it flows at different rates, because proximity to mass changes the tempo of reality. And the sun, our constant, our anchor, is not just a light source, it's a time machine. Let's return to something familiar. You're standing here on Earth. Gravity feels strong but not crushing. You live your life. You age. Your clocks tick with rhythm and reliability. Now imagine standing on Mercury, the closest planet to the Sunday. You're no longer just near heat. You're deep inside the curvature of space-time, closer to the sun's gravitational center than anyone on Earth ever will be. And here's the consequence. Your time slows down. Its small seconds stretch thin across decades, but it's real. Let's break it down. Over the course of your life, if you lived on Mercury instead of Earth, you'd experience about 38 fewer seconds than your Earthbound twin. 38 seconds, stolen not by fate, but by the sun's relentless pull on space-time itself. To you, everything would feel normal. Your pulse would beat, your thoughts would drift. But if someone pointed a telescope at Earth and observed a synchronized moment, they'd see you fall behind just a flicker, just enough to prove that time is not equal. But why? Because the gravitational field of the sun is stronger near Mercury, and gravity, according to general relativity, slows time by stretching the fabric of space-time itself. The closer you are to the source of gravity, the more warped that fabric becomes. Your clock still ticks, but the intervals between its ticks become longer compared to someone further away. Think of it like this. You're walking on a rubber sheet. On Earth, the sheet is gently curved beneath your feet. On Mercury, it slopes downward, more dramatic, more distorted. You're still moving, still walking, but you cover less temporal ground with each step. You fall behind, not in effort, but in existence. This is not theory, it's data. The equations that govern this effect are well known. They take into account the sun's mass, your distance from its center, the gravitational constant, and crucially, the speed of light. Plug in the numbers, and the outcome is unavoidable. Time ticks slower near massive objects. And yet, it's subtle. On Mercury, you lose just 14 seconds more than you would on Earth over the course of a lifetime, barely enough to blink. But what makes this profound isn't the number, it's the principle. Because if 38 seconds can be stolen quietly without your notice, then how much more can be stolen near something bigger, something denser, something darker? How much time can disappear near a neutron star, near a black hole? And at what point do the seconds become centuries? Mercury is only the beginning. It's our window into the concept that location is destiny, not just in space, but in time. Stand closer to gravity, and time becomes syrup. Move away, and time flows faster like water gaining speed down a hill. The sun, in this metaphor, is the hill's peak. It warps the stream, The planets orbit not just in space, but in time gradients. And we're all drifting down. Now here's the paradox. From your perspective, nothing is wrong. Time feels normal. Your heart beats at the usual rate. You read, sleep, think, dream. It's only from an outside observer's perspective that the slippage becomes visible. To them, your clock ticks slower. Your movements seem lagged. You live slightly behind. In this way, time is not a force acting upon you. It's a lens through which others see you. It defines your relational presence in the universe, and gravity holds the dial. This raises a strange question. If time can change depending on where you are, then what is the true time? The answer? There is none. Time is local. Time is personal. There is no cosmic stopwatch ticking across the universe. There is only your clock and their clock, and the discrepancy between them, each shaped by speed, by gravity, by motion, by mass. So Mercury becomes more than a rock near the Sunday. It becomes a symbol, a reminder that even within our small, familiar solar system, reality isn't equal. You can walk across planets, measure seconds with the same tools, and still find yourself out of sync with your own past. And when this becomes undeniable, when science confirms that even the sun can bend your age by a breath, you begin to wonder, what else is bending that you haven't noticed? What other illusions of sameness are quietly collapsing under the weight of cosmic truth? Because gravity isn't just pulling you downward, it's pulling you out of rhythm. The solar system becomes a symphony with no conductor. Each planet, each moon, each satellite plays its own tempo. Earth hums one rhythm, Mars drifts to another. Mercury, closer to the gravitational spotlight, plays a darker, slower note. And somewhere in this orchestra, you exist. Always slightly offbeat, always slightly alone. And maybe that's what makes this so quietly beautiful. Because the universe, for all its laws and constants, still makes room for difference, for asymmetry, for time to be a living thing, changing its face depending on where you stand. Mercury may only steal 14 seconds more than Earth across a lifetime, but those 14 seconds are proof that time is not fixed, that your age is not absolute, that your story is being written on a bending page, and in that bending, there is wonder. So the next time you look at the sun, don't just thank it for its light, thank it for this, for slowing time, for curving space, for revealing the lie of uniformity. Thank it for being more than a star, for being a clockmaker, a sculptor of time, a reminder that the universe does not move to a single beat. It moves to millions, and you are dancing to one of them, right now. What tells the time when no one is watching? Before sundials, before watches, before civilization, what was the universe using to keep track of itself? The answer is simple but breathtaking. The universe keeps time by how it changes. Everywhere you look, time leaves its fingerprints, in the swelling of stars, in the orbits of moons, in the decay of atoms, in the heartbeat of a pulsar flashing through interstellar space. Each is a clock, each a cosmic witness. We used to think time was something we invented, a human measure of the uncontrollable, but time is embedded in the fabric of reality itself, not because we decided it, but because the universe remembers. And it remembers through motion. Let's begin with one of the most accurate clocks in the known universe, the pulsar. Pulsars are the crushed corpses of massive stars, collapsed into neutron stars so dense that a single teaspoon of their matter weighs more than Mount Everest, and they spin fast. Some spin hundreds of times per second, beaming radiation like a cosmic lighthouse. And they do this with a consistency so precise, it rivals atomic clocks on Earth. One pulsar in particular, PSR B1937 plus 21, spins 642 times per second, and its pulses arrive with such regularity that we can measure the distortion of time itself across the galaxy. We are, quite literally, using the dead to measure the living, a corpse of a star, keeping the beat of space-time. But this is only the beginning, because the universe is filled with natural clocks, each ticking at its own tempo, each measuring time in a way that transcends human perception. The radioactive decay of uranium atoms takes billions of years, and from their ratios in ancient rocks, we know the age of Earth itself. The vibrations of cesium atoms define the second, not because we chose them arbitrarily, but because they are so steady, so unchanging. They are time. The expansion of the universe tells us how long it's been since the Big Bang. Every galaxy stretching away is a record of that original fire. Even your own body contains clocks. Your heart, your breath, your circadian rhythm, your aging cells. Every blink, every thought, every moment of awareness is part of a larger chronometer ticking across the ages. You are made of clocks tuned to cosmic time, synchronized to starlight and rotation and decay. But here's the twist. Not all clocks agree. Because the universe does not have one time, it has many. Let's go deeper. When Einstein showed that time is relative, that it ticks slower in motion and in gravity, he wasn't just revealing a trick of perception. He was unveiling a structural truth. There is no master clock in the universe. Two identical clocks, placed in different locations, one on Earth, one on a satellite, will tick at different rates. We've tested this. We've measured it. And without compensating for these relativistic differences, GPS satellites would drift kilometers off target every day. Your location shapes your reality of time. And that means the universe is not a single metronome, but a symphony of ticking hearts, each playing its part in the cosmic rhythm. The faster something moves, the slower it experiences time. The deeper it falls into gravity, the longer each second becomes. There are galaxies where time has passed differently than here. There are civilizations, if they exist, who may see the universe as older or younger than we do, simply because of where and how they exist. This is not science fiction. This is the architecture of reality. Now, consider this. If every part of the cosmos keeps its own time, how do we make sense of it all? The answer is both practical and poetic. We choose a reference. We set a baseline, a moment, a place, a perspective, and measure everything relative to it. On Earth, we define time by our orbit around the Sunday. But in astrophysics, we often refer to time since the Big Bang, the cosmic clock that began ticking 13.8 billion years ago, when space and time themselves were born. From that singular beginning, the universe has kept time not with gears, but with change. Galaxies formed, stars ignited, planets cool, life emerged. All of it, every cosmic event, is a timestamp in the memory of spacetime. But now we stand on the edge of a question too big for certainty. Is the universe's clock still ticking, or has it already ended just from a different perspective? Because here's the paradox. If time can stretch infinitely near a black hole, and if light from the farthest galaxies takes billions of years to reach us, then some parts of the universe may already be in our future, or worse, our past. We don't know, because we can only see time from here, from now, from us, but we can infer. We can triangulate. We can build models using pulsars, radioactive isotopes, supernova explosions, and ancient starlight. And from this chorus of cosmic clocks, we create the illusion of a timeline, a history of everything. And yet, something feels incomplete, because even with all this knowledge, we are still haunted by a deeper truth. Clocks don't create time, they only measure it. So what then is time itself? A dimension? A direction? An illusion? A loop? Or is it the consciousness through which the universe knows it exists? Every cosmic clock, whether it's ticking in the heart of a dead star or the neurons in your brain, is just a witness to the real mystery, that something flows, something moves, something becomes, and we call that time. We say time flows, but does it? We speak of before and after, of past and future, as if time were a one-way street, always moving forward, never back. This is what physicists call the arrow of time, the idea that time has a direction, an irreversible pull from order to disorder, from birth to death, from cause to effect. But here's the paradox. The fundamental laws of physics don't care which way time flows. Einstein's equations? Time symmetric. Newton's laws? Reversible. The equations work perfectly whether time moves forward or backward. In the world of particles and fields, there's no preferred direction. No cosmic this way only sign nailed to the timeline. So why then do we remember yesterday but not tomorrow? Why do we grow old but never young? Why do we see broken glasses but never unbreaking ones? Where does this arrow come from? The answer, as strange as it sounds, may lie in entropy. Entropy is the measure of disorder. It's why ice melts into water, but never spontaneously freezes in a warm room. It's why smoke spreads through the air, but never gathers back into a match. It's why your bedroom gets messier, unless you exert effort to keep it clean. Entropy always increases, and that increase gives time a direction. It's not that the universe prefers the future, it's that the universe prefers disorder. Or rather, disorder is simply more statistically likely. There are more ways for things to be messy than to be ordered. A shuffled deck of cards has trillions of combinations. A perfectly ordered one? Just a few. The early universe, moments after the Big Bang, was extremely ordered low entropy, hot, dense, smooth. Over time, entropy exploded, giving rise to complexity, stars, galaxies, and eventually, life. That transition from low entropy to high is what we call the passage of time. In a way, entropy is the clock. But here's the haunting part. If we ever reached maximum entropy, a state where everything is evenly spread out, no more heat differences, no more motion, no more stars, time itself might cease to have meaning. No more change, no more direction, no more memory. A heat death of not just energy but of experience. But let's not drift too far ahead. Right now, in this moment, you are a ripple in the entropy gradient. Your body burns calories. Your mind creates order. Your thoughts push against the chaos. Every heartbeat is a small act of defiance against the current of time. And yet, you can't stop the current. Not really. You age. You decay. You remember, but you cannot foresee. And still, the mystery deepens. Because what if the arrow of time isn't absolute? What if there are regions hidden from us where entropy decreases, where time runs backward? In quantum mechanics, time symmetry appears again. In the equations that govern the tiniest particles, outcomes are reversible. A particle can travel forward or backward in time on paper, and the math still works. And this raises uncomfortable possibilities. If time is linked to entropy, and entropy is statistical, not absolute, then time's arrow might be a local phenomenon, not a universal law. There could be places in the cosmos where time runs in reverse. There could be life forms, alien minds who remember tomorrow, not yesterday. We wouldn't even be able to communicate. Our perception of cause and effect would break down. Language itself would reverse. And here's the final twist. Some cosmologists believe the universe might be symmetric in time, that on the other side of the Big Bang, another universe exploded outward, with time flowing in the opposite direction. Not just a mirrored cosmos, but a mirrored timeline. A second universe, expanding backward from our beginning, where everything we see as future is their past. This is not fantasy. This is mathematics, explored in models like the CPT symmetric universe. And while unproven, it's a compelling answer to the question, why did time start at all? Because maybe it didn't? Maybe time always was in both directions, and we are simply caught on one side of the mirror, the arrow we feel is real for us. But for the universe, it's just one of two paths through the same tapestry. Now think of yourself again. You're made of stardust, you're powered by entropy, and your memories, your aging, your choices, they are all built on the asymmetry of time. But if the laws don't demand that time flow forward, and if the deepest equations say it can go both ways, then what anchors our perception? The answer may be consciousness, because time, as we experience it, is not just a line, it's a narrative, a memory of what came before, a hope for what might come next. Our brains write this story second by second, frame by frame, a film unspooling from reel to reel. Without memory, the arrow fades. Without change, the arrow dies. So maybe the arrow of time isn't written in the stars but in us, in the way we organize experience, in the way we crave meaning, in the way we say, I was and I will be, in the way we long for permanence, in a world that promises none, because time bends, stretches, loops, and slows, but we feel it only forward. That is the price of being human. That is the weight of entropy. That is the song of the arrow. You're here, reading these words. This moment, this fragile instant feels real, undeniable, the only thing that exists. We call it now. But what is now, really? Is it a slice of the universe, moving forward like a needle on a record player? Or is it a trick of the mind, a fleeting feeling painted by biology over something much stranger? Let's begin with the unsettling truth. Physics does not recognize the present. In the equations of Einstein's relativity, there is no universal now, no master clock ticking out moments for all to share, no cosmic stage where everything unfolds in sync. Instead, time is tangled with space. The moment you experience as now depends entirely on where you are and how you're moving. This is called relativity of simultaneity. Imagine two people drifting through space. One is standing still, the other is flying past at near the speed of light. They both clap their hands, but to each other, the timing won't match. What one sees as simultaneous, the other sees as staggered. Their now is not the same. This isn't a theory, it's measurable, it's real, which leads us to a chilling implication. There is no shared present moment across the universe. Your now may include a star on the other side of the galaxy exploding. Mine may not. For someone moving differently, that same event may not happen for 1,000 years. There's no agreement, no master now, no central truth. And yet, we live as if now is all that matters. Why? Because our minds demand it. We evolved to feel a present, to act in it, to respond to threats, to recall the past and predict the future. Yes, but only to serve the illusion of a continuous moment. That feeling, that razor-thin edge where life happens, is a neural construction. A story your brain tells, stitched together from sensory delays, memory processing, and predictive modeling. You're not actually living in the now. You're living in the recent past, buffered by milliseconds of delay as your brain interprets sound, sight, thought, and motion. You're always slightly behind, always catching up, always sinking a stream into a solid point. The now is not a place. It's a simulation, a constructed window of perception, a moving frame your brain slides forward like a film reel. But the film isn't real, the projector isn't perfect, the frames bleed, and in that blur, we believe in presence. But physics disagrees. Let's revisit Einstein's insight. Time is a dimension. Just like up, down, left, and right, time is simply a direction you can move if you have the right perspective. From the universe's point of view, every moment already exists. Past, present, future, they are all etched into the fabric of space-time, coexisting, not unfolding. The Big Bang, the fall of Rome, your final breath, they all reside in the great block of reality. This is called the block universe theory. Imagine the cosmos as a four-dimensional sculpture, unchanging, eternal. From within, you feel motion. But from outside, there is only structure. And in that structure, now is just your current address. Not a moving point, not a flowing river, but a location in the landscape of existence. And here's the twist. Just because you can't see other parts of the block doesn't mean they're not real. Your childhood still exists in another slice of space-time. So does your future death. So does the moment a distant star is born, billions of years from now, in a galaxy you'll never reach. You are a traveler through this block, but the road isn't being built as you walk it. It already exists. You're simply experiencing it, frame by frame. So what does that mean for you? It means the present is not sacred. It means now is not the ultimate truth. It means your sense of living on the edge of time is just a narrative illusion, a beautiful lie your consciousness tells to help you survive. And yet, maybe that illusion is what makes you human. Because without it, how would you love? How would you hope? How would you make meaning if everything already is? You see, physics may erase the now from its equations, but your mind brings it back through memory, through sensation, through emotion. You don't need the universe to recognize the present. You create the present, moment by moment, pulse by pulse, thought by thought. You are the fire in the cold block, the flicker in the eternal stone. Your consciousness injects warmth into an indifferent space-time. It carves stories from structure. It sings of presence in a world of fixed dimensions. And perhaps that's what now really island. Not a position in the universe, but a position of awareness. A point where the infinite becomes personal, where the map becomes a journey, where the cold mathematics of space-time meet the heat of being. Because in this illusion, this shimmering mirage of now, we find purpose. We laugh, we cry, we act. And sometimes, that illusion is more powerful than the truth. Because maybe it's not the accuracy of time that matters, but what you do with it. If time is not what we thought, if the present is a trick of perspective, if the future already exists and the past never left, then we are left with one final question. What are we? You see, everything we believe about ourselves, our identity, our memories, our choices, our regrets rests on the assumption that time flows, that we were one thing yesterday, are another today, and may become something else tomorrow. But if time is a dimension, not a river, then what does that make you? Are you a process? Or a sculpture? Are you the actor walking through the story? Or are you the story itself, already written, already complete, already there? This is the ultimate disorientation. Because if all moments already exist, if nothing truly becomes, but only is, then perhaps you don't move through time. Time moves through you, like light passing through stained glass. You are a lens, a vantage point, a conscious ripple in the still ocean of space-time. And your sense of motion, your becoming, is the universe looking at itself from one particular angle. Just as a mountain casts different shadows at different hours, you cast different stories across the surface of time. But the mountain doesn't change, only the light does. So if your memories are just points in space-time, if your dreams are just coordinates not yet experienced, then who are you? Really? Maybe there is no fixed you at all, only a trail of awareness, skipping like a stone across the fabric of reality. Each bounce a moment a flicker of the eternal, and yet, in the face of this terrifying possibility, something inside us refuses to yield. We still feel real, we still believe in choices, we still believe we can change. And perhaps that belief is more than a glitch in the simulation. Perhaps it's a clue, because even if the universe is a block, even if time is frozen, consciousness is not. Consciousness is the flame that dances through the corridors of the static cosmos, illuminating one room at a time. It brings motion to stillness. It brings life to equations. It brings meaning to a universe that, on its own, knows none. And maybe, just maybe, meaning is why the illusion exists at all. Maybe the present feels real not because it is, but because it must. Because without it, we'd be paralyzed. Stuck in the architecture of space-time, unable to move, to feel, to dream. The illusion of time may be the price we pay for agency, and agency may be the price we pay for existence. You see, the mind doesn't just observe the universe. It completes it by assigning meaning, by choosing paths, by making the infinite personal. And that is where the final illusion becomes the ultimate truth. That even if the cosmos is fixed, you are not, because in every moment, you have the power to focus, to choose, to act. Even if every choice already exists in some frozen corner of space-time, you are the one experiencing it now. And in that experience lies all the fire, all the beauty, all the heartbreak, all the triumph, and all the meaning this universe will ever know. Because experience is the only thing that matters to the experiencer. And you are that, a flash of awareness in the void, a witness to the miracle, not separate from the cosmos, but its voice, its echo, its soul. So what, then, is the final illusion? That time flows? That you are a self? That anything truly happens? No, the final illusion is that the universe is separate from you. It is not. It never was. You are not in the universe. You are of it, and everything you've ever felt, every breath, every heartbreak, every glimpse of awe, is the cosmos trying to know itself through you. And if that's true, if time is the mind of the universe unspooling its story one soul at a time, then maybe, just maybe, this illusion we call life was never an illusion at all. It was the point. So, here we are, at the end of our journey, or rather, one of its infinite cross-sections. We've traveled at the speed of light without moving an inch. We've unraveled time, bent it, dissolved its flow, and stared into the void where clocks lose their meaning. And in the silence between equations, we discovered something more powerful than any scientific formula, a mirror. Because in studying time, we were never just exploring physics. We were exploring ourselves. You, the one who breathes, remembers, chooses. The one who aches for meaning in a universe that doesn't offer it freely. The one who wakes each day thinking tomorrow is unwritten, even if the stars know otherwise. What did you learn, Time Walker? That the present is not fixed but constructed. That the past is not gone but still there. That the future is not potential but simply unvisited. And most of all, that the flow of time, the story you live by, is not out there in the cosmos. It's inside you. You are the river, and the current is your attention. Think of it. Every tick of the clock is just vibration. Every minute, a convention. Every second is a word we gave to something that refuses to be captured. But your awareness, that inner flame behind your eyes, takes this cold structure of space-time and lights it up with fire, with meaning, with memory, with hope. That is your superpower. Not to stop time, but to choose how you walk through it. Let's pause here, not for science, but for reflection. Because for all we've learned, for all the equations and paradoxes and theories, one truth still echoes louder than all the rest. You matter, not because the universe depends on you, not because time waits for you, but because within this illusion, within this temporary flicker of awareness, you carry something eternal. The capacity to observe, to wonder, to suffer, and still search. You are not just a collection of atoms bumping into each other according to cosmic instructions. You are a perspective that feels, a point of view that burns in the cold night, a consciousness that stands at the intersection of determinism and mystery and says, I am here, and maybe that's what the universe has been waiting to hear all along. Because in the grand, frozen block of space-time, in the swirling dance of entropy and gravity, there is no music until someone listens, no beauty until someone sees, no story until someone cares. And that someone is you. So don't fear time. Don't fight it. Don't mourn its passing as if it robs you. It is what gives you everything. The ache in your chest when you miss someone, that's time. The pride in your voice when you speak your name, that's time. The urgency in your steps when you chase a dream, that's time. You were never meant to master it, only to dance with it. And that dance, that sacred movement through illusion and memory and presence, is what it means to be alive. So, Time Walker, as you step away from this story, ask yourself not, what is time, but what will I do with mine? Will you wait for life to slow down? Or will you burn brighter against its current? Will you lament your limits? Or will you stretch every second into something vast, something beautiful, something eternal? Because if all moments already exist, then maybe the point isn't to reach the end. Maybe the point is to make the moment you're in worth remembering. And if that's true, if you are the fire in the frozen frame, then time isn't your enemy, it's your canvas. Paint it boldly before the next frame begins.